and I'd like to be able to continue to use the facility. So there you have it. Welcome. We will begin the pledge, and I will lead it today. So, I
pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Do we have any newly licensed folks with us today? Sort of. Tell me about sort of.
I got licensed a year and a half ago, something like that. I just didn't have to, so I don't have time, so I might as well do it.
I'm good with that. And we got someone else who's feeling you. Introduce yourself and tell us.
I'm Dane Allred. I'm in the same boat. I got my license and I was all excited about it then, and I just got so many things going I couldn't keep up, and now I want to get back into it.
Good. Good. So you two are both new the first time today? Do we have anyone else who's new with us today? You're welcome. Any license upgrades? Anybody gotten to the next level since we last met? Okay. That's coming. Teaching the general class right now. Pretty soon we're going to have a couple more generals, so that'll be awesome. Let's see, what else do we have here? Oh! Please take a look at our website once in a while, and particularly right now on Obey. There's a tab that says Obey on our website. We have 3 silent key auctions going on right now. And we are trying to help the widows recover some of what you know is your investment in your equipment that they patiently put up with all those years. And there's some pretty high-end equipment out there right now. There's a Yaesu FT5000 that's been sitting there for quite a bit. And there's a new FT101MP, which is pretty much their high-end radio right now from Yaesu. The 101MP, if one of you is not going after it this week, will probably go to the auction or to the swap meet next week down in Farmington. And there's a lot of other equipment out there. There's just about everything. Antenna analyzers, power supplies, anything that you might think that you could use. Let's go over our calendar. Next month, we've been booted. It's the end of the term for the school here, and they're going to have a huge party and take over the place, so we've been disinvited. We will meet at the Roy Library, 10 o'clock instead of 9. That is because the library doesn't open until 10. So we'll be at the Roy Library in the auditorium there at 10 o'clock. That meeting will be a meeting to discuss the future of the club, basically. We will get reports from each of the officers. They'll tell us a little bit what they learned about being an officer and what it's all about. And you'll be invited to consider thinking about being an officer in August when we have our elections. Before all that, we're going to have some fun this summer. So in May is Golden Spike. And we go out every year. May 10th is the actual date of the commemoration. And we will be out there on Saturday the 9th. May 10th is Mother's Day. And I don't know about you, but I know enough that I don't mess with Mother's Day. So we will not be there on Mother's Day. But we will be there on the 9th. We'll set up. I got permission from the ranger just yesterday to come a little early, so we'll set up at 8:30. They open about 9, and we could use a little help getting all that done. Tracy's our activities director, and he and I have been out there visiting with the rangers, and it's they look forward to having us every year, and we look forward to being with them. So that's May. In June is Field Day on the 27th and 28th, and we will be at the park, Marriott Slaterville Park, 12th West, about 1050 south or something. If you go to 1200, you just head north a little bit, it's just right there. Also, on June 27th and 28th this year is the air show. We're assuming it's still on. And if you're part of Weaver Aries or Davis Aries, those two organizations support the air show. You could find yourself doing any number of things, but our claim to fame is finding lost kids. We have 200,000 to 300,000 people on the tarmac. There's a couple of lost kids. So, anyway, we encourage you to come to Field Day if you'd like, and if you're inclined to help with the air show, that is a good thing too. In July, we will do our fox hunt that we do every year. If you find the secret transmitter, you get breakfast, so that's great. And then in August, we'll be back at the park over in Marriott Slaterville for our state fire elections. So that's what's coming up. Does anyone else have business for the club? Yes?
I'd just like to make a quick announcement about the swap meet you've already mentioned.
Sure.
We're having our Utah VHF Society annual swap meet in Farmington next Saturday. We get things set up around 8 o'clock, and a lot of people start buying and selling around 9. We'll have some light refreshments there if you're interested. And this year we're publishing our book, and we've done something different. Our publisher has done a real fantastic job on it. And we're not only having the small book that we've already had, but we've put a little larger print in it for all of us who can't read small print. And we've also created a large 8.5 by 11 booklet that we'll be selling for $10 if you want to have a large print booklet that will help you have the information about all the repeaters in the VHF Society. One other final announcement. The Utah VHF Society is hosting a new net on the third Thursday of every month from now on. Everybody's welcome. It's an information and training net. We're not trying to override anybody else's net, but it's going to be Thursday nights at 8 o'clock on the third Thursday of every month. And everybody's welcome to join. We're creating a check-in roster, and we've been asking people if they want to get on the check-in roster to email me. That's nm7p@msn.com, and we'll add you to the roster. If you don't send me an email, we'll get you on the check-in list as we do the net next time in April, and that'll be on the third Thursday in April. We're going to do it every month, and right now it's just a new net. We want to have it be a friendly information net, and it goes all over the intertie system. And one of the interesting things, we've got one of our hams that ties us into a link into Colorado called the Sky Hub, and that covers part of eastern Wyoming and a good part of Colorado and down into Albuquerque. So it's quite a wide area VHF, UHF net, and it's just on whatever repeater you get into the intertie on. So please consider coming and joining us, and we hope to have it be a very informative net for old hams and new hams and everybody who wants to learn more about ham radio.
Thanks, Val.
At the same location as last year, for the swap meet?
Swap meet, same location as last year. The only thing that's confusing people, the Legacy Event Center changed their name to the Western Sports Park. So it just come to the same place where it was. It's on our website, UtahVHFSociety.org, if you want to look it up on there to get information.
Okay. Anything else anyone has to share with us today? If you wish to join the club, please go to our website. There's a tab on it that says Join and Renew. So there you go. We try to make it easy. Today's presentation, I have borrowed from the State Fire Marshal's office. I saw this presentation at an emergency manager's meeting a couple months ago, and it struck a chord with me. It was talking about lithium-ion batteries and things that we should be careful about. And my mind was immediately drawn into my shack and all the little HTs lining the walls, the chargers in a shelf, and other chargers and things in my garage where I have larger batteries for our equipment. I thought, this would probably be good information to share with everybody. So, one thing about the presentation, when I saw it, you're going to see the same thing I did. Some of the audio breaks up on some of the videos that they present inside of it. So just be patient with that. What you'll see will probably overcome what you may or may not be able to hear in certain instances. So.
Is this online?
This is not online.
Okay.
Alrighty, I'm going to have to dim the lights so that you can see it, and I apologize for that. I need a brighter projector, I guess. Well, one thing I didn't do when I got here this morning was test my speakers, so I probably need to do that as well. Steve Higley was the Deputy State Fire Marshal who presented it when I saw the presentation. And it comes from a fireman's perspective because they're the guys that have to deal with this stuff. And we'll talk about the batteries, impact on fire, risks, and all that good stuff. All right, let's just get right to it. There's a disclaimer here, so if anything crazy is in there, it's not their fault. It's not my fault. It's just what was there. Any photos or images used that look like they belong to somebody is merely coincidental. In addition to this presentation, part of what I'm going to share with you came from another training that I participated in just a couple weeks ago from UTA. UTA is getting about a dozen EV buses. We're going to put them in service on I think it's a 12-mile route in South Jordan, coming up shortly. And the training was for UTA with a consulting group that was teaching them what to do in case things went sideways with a bus. So part of that will come a little bit later. And I do have a handout for everybody when we're done. That's dessert for the presentation. And it includes information from both of those sources. Okay, we all use them. They're all probably in our pocket right now. I see one illuminated. And so they're everywhere. The one thing I didn't talk about in there is radios, and of course we're using them. They're efficient, they're convenient, and we love them. But they are starting to create a few more fires. But we're going to talk not only about the fact that they have the potential to be dangerous, but why and what to look for before you have a problem. Because inherently, they aren't necessarily dangerous in and of themselves. But there are a few things that can trigger that. Okay. They spread fast, they burn hot. They don't even have to have been charged. They can have been sitting for years and then spontaneously combust. So, the larger the battery, the larger the issue. And we're going to talk quite a bit about thermal runaway incidents. Thermal runaway is when things really get crazy. And that's what we saw with that laptop. It got to a certain point with their internal temperatures of the battery were exponentially going up, and it became a thermal runaway. And when you're at that point, the only thing you can really do is get away. And you'll see in a minute that get away means 50 to 75 feet. So we'll talk a little bit about chemistry and designs here in a minute. Sorry about that quality, but this guy, where it says StacheD Training, you notice the stash, fire service, right? But if you go to his website he has a whole lot of YouTube videos that are very good, and I've got that information in the handout here for you, where you can go just take some of his training. So how they're designed. They have different types. They have cylindrical, they have the pouch, they have prismatic. And so there's film that's wrapped up inside of them. And we're going to talk a little more about the composition of it here in a minute. So I'll try not to get ahead of myself. So you can have an individual cell that provides a specific current and voltage. You can have a module, which is a group of cells that are put together either in series or parallel. And generally they're controlled by BMS, a battery management system. You can have a pack, which has multiple modules, and you can have a system. Now, when you have thermal runaway, one of the biggest problems with thermal runaway is propagation. We think of propagation in a little bit different ways. But that propagation is one cell that ignites the next, ignites the next. So the components in it, and I think he's got a visual here in a minute too, but there's going to be a separator in it. And then there's the solid electrolyte interface, the SEI. The SEI is formed the first time you charge the battery, and it's just basically a chemical interaction that happens. You have electrolyte, a positive ion source, then you've got your anode materials and your cathode materials. I have more about that if I could read it, but I don't have lights on here. Anodes are generally graphite. The cathodes are some kind of precious metal. The electrolyte is a paste or a gel that is organic and very flammable. There's a separator between the anode and the cathode. The anode and the cathode don't get along very well. And they're just itching for a fight. And if anything happens to the separator and they get together, that's when you see some of the things you just saw in the videos. So we know what a battery management system is. It's got hardware, it's got firmware, and it controls the charging rates and all that good stuff. So if you alter anything associated with that in the way that you think you want to charge your battery because you have a better way of doing it, it will probably void whatever warranty you may have had, and it may not end well. How it all works. There it is. We've got our cathode, we've got our anode, there's your separator. This is that SEI layer that forms. So the first time you charge it, it creates that little layer there. Now you notice she said that it was 20 degrees centigrade per minute. an increase in the rate. It wasn't just achieving that temperature. It was an increase as it was running around. Okay, which is around 68 degrees Fahrenheit per minute. So if you get an internal temperature between 300 and 500 degrees Fahrenheit, then you've got some issues. It starts rapidly decomposing the components. You're going to start seeing signs of that, such as a swelling, or it starts emitting smoke. The temperatures of 750 to 930, you start to have reactions. 1200 degrees and up, the thermal runaway is in full. It's just there, and it just gets worse and worse. And those are general, and it depends on the components and the materials that they actually made the battery on. Yeah, it's hot. The first thing in that video it showed was a puncture. Did you notice? They put some kind of a press and punctured it. That is one of several causes of thermal runaway. You have heat, excessive heat, from overcurrent, from resistance, external radiation. We've already talked about most of that. But the electron flow is no longer controlled. Mechanical damage, puncture, dropping, and dendrite formation. I don't know what dendrite formation is, but I know what it takes to drop a cell phone. And I'm wondering if when we had all of those issues on airplanes some years ago with cell phones that caused the FAA to get a little crazy about it, those cell phones have probably been dropped pretty regularly. The batteries may have already been swollen from the damage that had been done to them, but nobody thought about that or took into consideration that maybe they ought to replace the battery. It could be a defective design or construction. So if the separator's damaged during construction, then you probably bought a product that's going to be more dangerous for you. Why is this so important? In the very first video we saw, we watched unguided flying objects going everywhere out of that laptop. Many of them were actually burning, which meant that as it shoots materials out that are ignited, they can an ignition source for other materials that are dry grass, cardboard, paper, whatever it is. Toxic fumes and gases, and then of course just the heat. When thermal runaway occurs, there is little time to escape. So if you start seeing evidence of that, it's time to back off and get away. So there's effects on the human body that are hard to read. This is current in milliamps. So it just basically says if it's less than 1, you generally can't tell. If it's 1, you get a faint tingle, and it goes all the way up to extreme pain and death. We're looking at 3.7 volt driven milliamp flow. If the current is 50 milliamps pushed by 50 volts, it can cause muscle contractions, breathing difficulties, ventricular fibrillation, which affects our hearts, of course, and Iacus Viola. Should be familiar to us. So individually, they're generally not a terrible thing, but if you've got a pack of them and they propagate, it becomes a bigger deal. Toxins, synergistic effects. If you get a big cloud, it can be hard to escape or avoid it. Some are actually heavier than the air, some are not. So you have inhalation, ingestion, absorption, and injection. All of those different things you can be affected by. So if you have that emergency, extinguishment and reporting are critical. For us, it would be reporting. Water doesn't necessarily help. In fact, in some cases it hurts. But fire service has to make those decisions.
It's a comment.
Yes?
The training I had a long time ago, they said that throwing water on a lithium fire is like putting gas on a fire.
It can have that effect because it breaks down the structure inside. If it's breaking down the separator, then you're causing the chemical reaction that's going to cause it to get worse. There are times they'll use water just to try and cool it and keep it from getting to a thermal runaway, but it takes a lot of it, and they have to consider the fact that while they're doing that, they're probably breaking down the separator, and they may or may not actually be helping that incident. It's incident dependent. But you're absolutely right about the water doesn't necessarily help, and that would be our first inclination. Most people would think, well, I'm going to douse it with water, because I see that fire departments doing that, putting out house fires. May not be the best approach.
I think also they use a Class D fire extinguisher for that. Not 100% sure. Another one I'm using.
Yeah, if we were to talk about EV fires, for instance, they'll use blankets. They'll try and smother it that way. But these are not oxygen dependent. Everything that, like you said, everything that is needed for that fire to happen is already inside those cells. It's all internal. And if there's some type of an internal thing or external puncture or damage, it may not be effective. When they were giving me the presentation before, one of the things that they talked about was putting a blanket over it. And the problem with the blanket was twofold. One was sometimes the blanket's not enough and it burns through. The other part was when it was time to take the blanket off to see how effective it was, as soon as they took it off, it reignited. So, now those are large fires. We're talking vehicle fires and stuff like that for that. But you try and starve it if you can. Eliminate fuel. If you're familiar with the fire service and if they have a levee on a tanker car on a railroad, what are they going to do with it? They're going to let it burn because they got to get rid of the fuel. If they got a string of 4 or 5 tankers, they try and separate it from the rest and then let it go. Because that's the safest thing to do with it. Okay. So extinguishment, come down. Containment within the battery denies access to extinguishing method to work, forces copious amounts of cold water applied outside, trying to reduce it. Understanding that it might be making it worse. Okay. He speaks really slowly so we can understand. Go go out to his website and watch this video. When they incorporated it into the PowerPoint, they really messed it up, sorry. But what he has to say is pretty exciting. Okay. They have a whole bunch of stuff in here about reporting and national codes and fire codes and all these other things that we're not going to worry about so much. Sure. So, things to think about. Egress. Fuel load control. Control of ignition sources, training. And again, these are fire folks, and they're worried about people's safety inside of buildings. That's what this presentation was geared towards. So means of egress is a continuous unobstructed path, vertically or horizontally, to be able to get out of an occupied portion of the building. So what they're trying to tell us is, don't store things within the means of an egress component. Don't put something that could explode in the way of your getting out the door. That's plain English of what they're trying to tell us. Yeah, more stuff. So in the context of fire safety, fuel load refers to the total amount of combustible materials within a structure. So that means what's the total amount in our homes of propane, gasoline, lithium-ion batteries, anything else that could cause or could be a problem if we had an ignition source. Separate out the charging and storage areas. Consider charging larger ones used in e-scooters, e-bikes, lawn equipment, all that stuff outside, out of the weather or the sunlight. Why would you want it out of the sunlight? Because in the summertime it gets warm and heat can trigger a thermal runaway if all of the conditions are just right. Limit the charging and the storage of the energy amounts to what is needed. And we're told that with our batteries anyway. If we store a long time, don't leave them in your radio. Go take them to 80% and then use that as storage. And then when you're ready to use them, if you want to fully charge it, go out for a day on an event, it's ready to go.
Would you say that again? About charging.
If we're storing batteries over a long period of time without intending to use them, the recommendation is to store them at about 80%. And then, if we're good and ready to go on an event, where we're going to take our HD and we're going to go out and do a race or a food drive or whatever it is we're doing, we charge it the night before up to 100%, and then we have it ready for we're going. But we are encouraged not to leave them on chargers or have them 100%. A lot of us do it anyway, and I know that. I've done it. I'm rethinking a few things, having watched this presentation. My wife has a scooter with a big battery in it. It's the way she gets around when we go on vacation. Without it, we wouldn't be able to move too far. I charge it in its own little area, but it happens to be inside the house. I try to make sure that I don't overcharge it, and I pull it off the charger and just don't leave it there for months at a time between vacations. I was reviewing this presentation 2 days ago, and all of a sudden it dawned on me that the night before I plugged in a fairly decent sized battery into a charger in my garage for a blower. And it was still there after being there overnight and all day, and I thought to myself, maybe I ought to pull that off the charger and stick it in a different place, which I did. And it was charged and now it's ready for the next time I got to take care of leaves. But it's so easy just to put something on a charger and leave it there because it's convenient. And we want to make sure that, hey, it'll be fine. If the battery management system's good and working, it should be fine. We rely upon that. But if for any reason that fails, it could be a problem for us. Okay. Places that need to be off limits to storage or charging. Any place that's in the way of you being able to get out of where that space is. Occupied spaces, classrooms, labs, assembly areas, office spaces. Well, I charge a lot of things in my office. Mechanical spaces where they're part of an air return, where if you were to have an ignition in a fire, that air return could spread it throughout the structure. Spaces where communications and alarm control panels are located, so that it disables the communications of being able to alert somebody if there's a problem. Again, this is building maintenance type thing, so that's where that comes from. Similar or other as fire suppression controls, life safety controls, and all that good stuff. Okay, 25 feet from the exterior exit door or exterior window. This is what they're talking about. Now, on my phone, I have pictures from one of our operators who moved away some time ago, and I was helping him get things arranged. His entire basement was close to that, except instead of cardboard boxes, it was radio equipment. He had shelves and shelves and shelves of everything. His fruit room underneath the porch was filled with shelves of everything. And I hate to say it, but if I were to look at my office, I organize in piles and stacks, and I probably need to be a little better about it before. Okay. So batteries are not considered unstable or reactive due to properties associated with the chemical composition within them. So the requirements of the IFC 66 or 67 don't apply to them. But due to the behavior, some things do apply, and then they give you other sections that I have not looked at. Definitions of what an ignition source is and other things. The bottom line, ignition source is any item, condition, or process capable of initiating combustion or explosion by providing sufficient energy to ignite a flammable or combustible material. Now, I think they're going to get, maybe they're not. So we need to go back to what causes thermal runaways: puncture, damage from drops or falls, bumps, submersion in water. It doesn't mean you can't have water associated with them, but you don't want to submerge them in water. In the presentation for the buses, Gillig, who's the bus company, was on the call, and they were doing some training. The question came up from UTA, which I thought was a pretty valid question if I was going to ride a bus. What happens in the winter or the spring? What happens if I'm driving through puddles? What happens if the snow is deep and it starts to melt? What happens if it gets packed up in the wheel wells and there's moisture all over? And the answer was, that type of moisture is not necessarily a problem, but don't run it into a lake. Don't get it into a river or a canal. Don't get that battery submerged, because then you're definitely going to have a problem. On those buses, many of their batteries are up top, the same as they do with the natural gas, where they put the tanks on top of the bus instead of at the bottom. But some do have them underneath. Battery pack fire, propagation going between the cells. Sweetie? Did you notice the size of that plume when it started to grow? Those were toxic gases. Okay. Guidelines. Follow the guidelines. Always use a charger that's certified for the battery that you're working with. Don't mix system components from different manufacturers. You don't know if they're running a common standard or they're just doing their own thing. Scheduled charging and supervision can occur. I'm a terrible example of that. I'm going to put it on charger, I'm going to let it go overnight, and then I'll pull it off if I remember. I think most of us do that. But pay attention to visual indicators. So the battery is swelling at all. Probably time to find a way to properly dispose of it. We need to talk about proper disposal. The landfill, the transfer station, is not interested in our lithium batteries for the very reason that we are worried about getting rid of them. Think about having a lithium battery in your garbage can. The truck comes, clamps around it, lifts it up, dumps it upside down, drops it into the truck. If it's already somewhat damaged, that probably didn't help it any. Then, the truck is going to compress all the garbage, and they're going to take this great big plunger and squish it all together. Well, that probably isn't going to help either. And eventually, what may happen, if it doesn't happen in the truck, which it has, because during this presentation, we had a representative of the Wasatch Integrated Waste Management people there that run the landfill in Layton. They've had combustion in their landfill from batteries, and they're really hard to deal with. It's almost like a tire fire. It just goes on and on and on. Well, pay attention to those visual indicators. Don't overcharge. So the VMS will help you, but if the VMS fails, then we're back to where we started. Okay. Inspect them before we use them. If it looks like there's any corrosion at all, probably not a good thing. If the battery's not lasting as long as we expect, it's probably starting to break down and fail. Dancer punctures are not great. If the battery's unusually hot, the cell phone I had before this one started to overheat constantly. And it wasn't just from charging, it was when I was using it. And it wasn't just warm, it was hot in my hand. And at that point I decided it's probably time for a new phone because it was an internal battery, I couldn't replace the battery. And I took it out of service because I didn't want it to decide it was time for a thermal runaway in my pocket.
Right.
Yes?
How did you dispose of it?
At this point, I have kept it in a separate place in a bag, like I do most of my cell phones. But if I were to dispose of it, I would either take it back to a cell phone company and ask what they do with them, if they collect them. I believe Batteries Plus has does some recycling, and I'm told that Home Depot and Lowe's, if you ask them, have some capability of recycling batteries. I know at the landfill in Layton, right before you get in there, there's another building, and they do recycling of electronics there. And I have not asked them specifically about lithium-ion batteries, but I've certainly given them a lot of OTEs. But that's an excellent question. I need to do more research on that, on how to properly do it.
I think Best Buy does too.
Best Buy probably is. So it's not lasting, if it's dense, if it's wetness or discoloration, if it's unusually hot, if it's bulging. In fact, it says if it's bulging, thermal lightning, runaway is lightning. Now, if it's releasing vapor or gas, that's the time to get away. And hopefully it's not in a place that's going to cause a lot more damage just because it's in the middle of your home. If it's bulging, that's a laptop battery. There's a puncture. We already talked about not altering battery systems and charging systems and all of that. So batteries have been known to burst into flames when it's above 265 degrees Fahrenheit. And remember, when you're starting into a thermal runaway, there is a rate of increase on that temperature. And if that rate of increase is over 20 degrees centigrade or 68 degrees Fahrenheit per minute, then they're in trouble. Try and keep them out of direct sunlight. Don't cover them because that traps heat. Don't use multiple batteries with a single charger unless the charger is built for that. And the charging is very expensive. Unplug the charger when it's no longer in use, and I'm not sure why that is, and I don't do it. Maybe I should. I think that might be just being overly cautious. Remove the battery from the charger, especially if it's longer periods of time, and I try to do that. Okay. So here's an important thing for us. Batteries retain more stable charge between temperatures of 40 and 110 degrees Fahrenheit. I'm told 70 degrees internal temperature on a lithium-ion battery is probably optimal. So I would expect that with all my batteries in my home, which is generally somewhere between 68 and 74 degrees, they should be just fine.
Craig, on charging,
Yes.
when I got my last iPhone, they said just charge it to 85%.
Mm-hmm.
And I was having to watch it, and then I realized I could actually go in. My phone has a setting
Yes.
that limits how much it'll charge. So I have it set at 85. It charges up to that point, and then it does not charge anymore.
The Android phones have something similar to that, and I turned that on my phone as well. It's basically a BMS type thing for your battery, and it is allegedly, if you use that, it will extend your battery life, so you don't have to buy a phone every couple of years because your battery's gone out through obsolescence.
That's why they said to use it, but it sounds like it'd be better not to charge it to the 100% all the time, just for safety reasons.
Charging to 100% is probably not the biggest problem. Overcharging it would be if it is unable to handle getting shut off at the right time. So charging at 85% is probably great. It's great if your phone lasts all day at 85% charge. If it doesn't, you might need a little bit more of a charge, or you have to charge it during the day, which is inconvenient. Okay, there's no regulations that you must recycle lithium batteries, but it's probably a pretty good idea to make sure wherever we do dispose of them is going to be a place that's safe. We don't want them in a garbage truck, a landfill, or a solid waste processing facility. Because obviously you've got a lot of other fuel you're putting it with. Okay. Here we go. Home Depot, Lowe's, and Staples are partnering with Call to Recycle to offer a free recycling service. The maximum weight accepted is 11 pounds and limited to less than 300 watt hours. And your recycler may not want to take them, so it might be a good idea to let them know and ask them first. There are a lot more sources for training. And that is what they have there. This came from the UTA training. It was the people who were the consultants put this particular slide together. And they were talking, of course, more about vehicles. And they sort of went over the same type of thing where you've got plug-in hybrids, you've got high voltage components throughout the car, more than just the battery pack. We've got level 1, 2, and 3 chargers, which are more juice to be able to charge it more quickly. And then they talked a little bit about what can go wrong, and we've just talked about pretty much all of that. And one of the other things that they talked about, let's see if I've got it here. So recognizing problems, and this again is for vehicles, but it could be other things. If there's arcing or sparking, smoke, gas, fire, physical deformity, leaking fluids, a sweet electrical burning odor, buzzing, popping, or hissing, which could be an indication of a thermal runaway that hasn't, it's just starting and it's inside before it really gets big. And they're highly flammable. Thermal runaways run at about 2,600 degrees Fahrenheit, which is why they're so dangerous and they'll ignite anything around them. And that went back to the first one, so that's all we got with them. So, the intent was not to scare everybody to death, but to inform and to give us an idea that the batteries are dangerous when something happens to them. If we're taking care of them, we're not dropping them, we're not puncturing them, we keep them at an internal temperature of about 70 degrees, we shouldn't have any problems at all. But other things can happen, and when they do, and if you're seeing it, probably the best thing to do is get on the horn, get somebody coming, and to get away from it. Let the people who know how to deal with it take the risk, yes.
So we have a couple of e-bikes with the big lithium batteries, but they make pouches for them, flame-resistant pouches, which we store the batteries in these pouches. I
Okay.
don't know if it would actually stop the fire, but it would slow it down a little bit and give you a little more time.
That's a
Get
great
more
idea.
hands-on.
I probably should have one of those for my wife's scooter. For batteries.
They're like real
That big.
thick, light material, and supposedly flame-resistant.
Okay. Because smothering them, they often use a tarp to try and keep it smothered. But again, if we're taking care of them and we're not dropping them, we should be okay. Yes?
The lipo buttons that I use for POTA and stuff have a Bluetooth app inside the BMS.
Right?
So it's tied to my phone. If I've got it out in my shop, it will send me a thing and say, hey, I'm done charging.
Okay.
Why don't you come and plug me? Or it will just tell me that it's, you look at it and see the health of it when it's out in the shop and stuff like that.
That's a great idea.
I think lipos are better though. These are lithium-ion.
Yeah, lithium-ion, yeah.
They're earlier technology. These are the Teslas that you see on the news that burn, and it takes 60,000 gallons of water to put them out, and that's just...
And it's not putting it out.
It doesn't.
It's just letting it burn and trying to control it while it's
Yeah.
burning.
So...
Yeah.
Yeah, the lipos, and then I do have a lithium-ion one version too that does Bluetooth with a BMS communication.
Your
Now,
typical
we-
ham radio, though, does have
Yeah.
lithium ions in it.
Yeah.
Just because those were cheap, and I mean, those came out 20-something years ago for ham radio use, and they were revolutionary. Now you can't put them in an airplane unless they're in your carry-on kind of thing. I don't know whether or not that. You don't want it in the cargo hold with the fuel, so. I'm sure the flight attendants are trained on how to deal with somebody's battery catching on fire. So.
So here's another thing that you're talking about, is isolation on vehicles. Because if they have, even though you've had a vehicle fire and you think, okay, it's out, it's done, they can reignite at any time. And one of the things that they suggest is putting them into isolated bays, which they've had instances where it reignites anyway. They've had vehicles that have been untouched for 2 years that suddenly recombusted. And the problem that the UTA folks were trying to work through with these guys is, let's say we have an incident on top of a bridge, or we have an incident underneath a bridge. It's already starting into thermal runaway. We're told to stay away from it, but you're going to damage a structure potentially and cause even more problems. How do you get that vehicle the size of a bus moved safely? Well, they're working on different things to try and figure that out. They do have the tow hooks and things around them. They're trying to figure out how to put greater extensions on tow trucks that can get there, lift it, and pull it out, and other things like that. But those are the issues that the engineers at ETA are trying to deal with and figure out how they can safely assure the public that they're not going to have any issues. So that's just the specs on what they were doing with that. Let's see, what else do we have in here? I think we've already got that. Vitamins. So you can see they're trying to figure out ways where they can get the thing from being submerged. If it's submerged, it's almost guaranteed that they're going to have a thermal runaway. They will be compromised, and they've just got to get it out of water as soon as they can. Or they just let it burn and let the water boil. Okay,
So I'd say,
yes.
by the way, I'm Rick Ward, forgot to introduce myself. But on Route State, we had a lithium-ion fire in storage where students had stored some drone batteries in the corner. They spontaneously combusted. We called the emergency services like we were supposed to. They came and sprayed the kind of fire extinguisher. They sprayed about 10, were just smoldering. They sprayed a 10-foot radius around it. So they pretty much covered it with all green. And then they said after it was all over, it was too dangerous for us to clean up. We charged us $15,000 to clean up all the wiped out. So it's not cheap when something like that happens.
Yeah. Like I said, I'm not trying to discourage anybody, but I think we should be aware. And these things, it's like anything else. It only makes the news when something really spectacular happens that's spectacularly bad, and usually spectacularly good doesn't get reported anyway. But if it's something that's a real concern, you're going to hear about it. And there aren't that many times where that comes to the surface. There are more and more electric vehicles on the road, and so they would expect that there would be more and more incidents just from accidents, or inadvertently running and getting submerged somehow. But that doesn't mean that we need to worry too much about everything. I mean, we could worry ourselves to death with other things as well as this. I think we just consider what it might be to be better prepared. Make sure that we don't have anything in the way of an exit. If we put all of our charging equipment and everything right next to the door of our office, maybe it should be at the back side of the office, someplace where we would have the ability to get away from that kind of thing. Any other comments, questions? I'm not an expert on this. I just got exposed and all of a sudden it was like, it's probably something I'm going to think about. Yes?
I think it was Justin that had a comment about LiPo versus some other. Can you explain that? I didn't quite catch
The
that.
lithium iron phosphate batteries are newer. They're the kind of follow on to those lithium-ion batteries. These ones, they're very light. I don't think they have the fire hazard that these do. I've got a whole bunch of them, and I've never had any problem with them.
The lithium iron phosphate, I bought a big one from Costco. I was just buying stuff from Costco. They claimed it was much safer. There was lithium ion, there was iron phosphate.
Yeah, and those are a lot safer. I don't know of any fires with those unless someone like deliberately lit it on fire. But I don't know if they burn. I just know the lithium ion ones, those first generations, they're a little sketchy, and it's but to be aware is to be safe. But yeah, LiFePo 4 are great batteries. I've got.
Well, that's a great question, and we actually asked the question of the fire marshal, and he said all lithium ion are about the same. I didn't totally believe that, but one of the things about any of these batteries is they're constantly working on different formulations. They're using different materials, and adding iron into it apparently helps. It probably doesn't take away all risk, but it's probably a lot better. Being the fire marshal guy and being the guy who's supposed to guarantee our safety, he wasn't going to tell us that. He's been talking to too many attorneys, right? He doesn't want to have any liability because he doesn't want to be the one that said, well, this will save you, this will never happen. It could. He was sort of on the other end of the spectrum saying, no matter what it is, you could have a problem.
Sure.
In their world, when they're looking at fire ignition sources and just actual fires, just about anything in a home becomes a hazard for them.
Well, they've seen everything.
They have.
And lithium is like sodium. I mean, it's very reactive with air and water. It's an unstable thing, and so they mix it with things to kind of stabilize it, but it doesn't stop being lithium just because it's mixed with something else.
And remember, the way they're constructed is basically it's in layers. So they've got that separator layer there, and if it's a rolled up battery, it's just rolled up layers. So if you somehow are able to penetrate or damage the separator, then that's when you're going to have a problem regardless of what your chemistry is. Now,
Power tools that we use, what else we want to do. What type of batteries are they?
Those are lithium.
those are the
So those are the ones that...
So the truck that you saw blow up, the smoke came out, that came off of a power drill that was in his truck.
Don't store it on a gas can.
Container. Toolbox. This toolbox on his truck. It was out in the heat. It was a metal toolbox. The sun was beating down on it. And apparently, it was just enough heat to trigger it.
And
Now,
batteries-
everybody, sorry.
The batteries that caught on fire at Root State were the cheapest lithium batteries the students could buy.
Yeah. And they probably were the first generation, and that was probably more. Sometimes they do recommend that you buy like a hazmat cabinet. Anybody who's been in any kind of a maintenance world or public works or something knows that you get these great big cabinets, you put all your fuel in it, and you put all the other stuff in it, because if you ever get an OSHA inspection, that's one of the first things they're going to look for. And so they recommend that you get some kind of cabinet like that, keep your chargers in it, and do something behind closed vaults.
Yeah, remember it says about thing, that means you need to, it means beware in Chinese. So don't leave it on there, because if that stuff fails, then yeah, it's going to thermally run away. But don't trust them.
Casey's not here, so to defend about things, because he's the defender about things. About bangs or bang fangs or whatever you want to call it. Yeah. And I have a lot about bang radars, and they're great. The newer ones are actually pretty decent. The older ones, not so much. So anyway, I'm not to the point where I'm thinking I'm going to store my radios in a radio safe the same as I store my firearms in a safe. Yes.
This may be a real dumb question, but let me throw it out and see what people think. If things are so susceptible to overheating and things, what would be the problem with putting them in a refrigerator or a freezer that you buy dedicated just for that purpose?
I need to do a little more research on that, but I heard a rumor that, like most things, you have a standard operating range of temperatures, and you can go too high, and possibly you can go too low.
Okay.
Don't put it in crisper.
The air fryer is probably not a good idea.
4th of July.
Kenny?
So if you put these in, like you talked about putting them in a safe, if that safe is sealed up relatively well, all the ingredients for the explosion and the reaction is there, are you making a bigger problem?
Who knows?
So I use these little
I've wondered about that,
So-
honestly, because, again, it depends on how much material you have.
Right.
How many of these do you have in that safe? And are some of them the scooter-sized, e-bike-sized type things, as opposed to just the little things that we put into our radios? Consider that a thermal runaway is 2,600 degrees. Is your safe able to handle that?
The fire rating, how long will it handle that much temperature? So if it runs out of fuel before it exceeds that 30-minute rating on the safe or whatever,
Right.
you might get lucky.
And we watched a laptop that had been damaged, thrown away, hadn't been charged for however long it was that it was sitting out there, and you watch for 10 minutes while it was spewing materials out at high heat.
And the 4,000 PSI.
Yeah.
But Kenny, the other thing too, remember the temperature swings. That's when stuff starts to break down, when you go hot and then cold and hot and cold. And you're safe. You're staying relatively between the 40 to 70 degrees.
Probably, you're going to be,
You're again, I think you're reducing chances because you're not having that swoon.
and I think I would agree with that.
Because the materials that are inside, you know, if you keep doing that back and forth, just like a mechanical bushing, you wear it out when it's running all the time. Same way with an electrical, when you're swinging temperature-wise, it starts to wear out and break down, then that's when you start shorting and problems happen.
Every ham radio guy starts out with one radio, and then you got 10 of them in the safe after 3 years. So, you know.
I'm going to start a new radio company called Rabbit. It'll multiply. Yeah, that's kind of the way it is. Well, let me give you these. On the one side is from the state fire marshal's office. On the other side, the very first thing I put up there was StacheDTraining.com. Go out to his down from his website. Look at some of his videos. They are excellent. And remember, he's coming from the New York Fire Department. He's seen the worst of the worst. He's going to show some of those things. That doesn't mean that we are going to be affected by the worst of the worst. Could be. Most likely, we're going to be okay if we're careful. So, please come and grab one of these when we're done, which is right about now. If there's no other questions or anything, you can take a minute and hobnob if you'd like. And we will see you next month at the Roy Library, 10 o'clock. Come and listen to all of our officers tell you what an officer's like.